Hello, geometry people. We're about halfway through our chapter on ratios, proportions, and similarity, and we're continuing today talking about parallel lines and proportional parts. So as always, pause the video if you need to, or hit the rewind button. The triangle proportionality theorem says that in any triangle, a line parallel to one side of a triangle separates the other two sides proportionally. So let's break that down a little bit. If xy is parallel to rs, okay, so I've got those green lines there, that means that rx over xt, so there's rx, there's xt, equals sy over yt. And then the converse of that is if rx over xt equals sy over yt, then those lines that we started with, xy and rs, those are parallel. So let's practice this a little bit. We've got a couple triangles here, one sort of embedded in another. We've got some parallel lines. So we've got since EF is parallel to CB, we've got those parallel lines, then we know that AF over FB equals AE over EC. So let's look at that on the triangle. We've got AF over FB equals AE over EC. And there's the proportion that we set up. X plus 22 over X plus 2 equals 18 over 6. And then we can cross multiply and solve. 6x plus 132 equals 18x plus 36. Get all the x's to one side, the numbers on the other, and we get x equals 8. All right, let's try another one. We've got our parallel lines here, so we can set up our proportions. We need to know this guy here, though. Like this little guy here is 20 because if this whole side is 28, then we know that's 20. Okay, so now we can start setting up our proportions. We've got these parallel pieces and parts, so we've got 10 over 3x minus 5 equals 8 over 20. And then, once again, cross multiply and solve. 200 equals 8 times the quantity, 3x minus 5. Go ahead and distribute that 8 through the parentheses. Add 40 to both sides, divide by 24, and you get x equals 10. This problem's similar, but we're kind of coming at it from a different perspective because what we want to know is if two lines are parallel. So it says in triangle GHJ, HK equals 5. So let's put that there. HK equals 5. KG equals 10. Okay, I've got that. And JL is 1/2 the length of LG. Okay, that's kind of a mouthful, but here's what we're going to do. We're going to let JL equal x and LG equal 2x. And then that makes sense, right? JL is 1/2 the length of LG. Okay, so now the question is, when we set up our proportions, does x over 2x equal 5 over 10? So if you cross multiply, you get 10x equal 10x. So yeah, that works, which means that HJ is indeed parallel to KL. Okay, so the next thing we're going to look at is called the triangle midsegment theorem, which says if x and y are midpoints of RT and ST. So let's pause that and put that on our figure here. So x is the midpoint of RT, which means that this spot RX and XT, those are congruent. And then y is the midpoint of ST, which means it breaks up this side into congruent pieces. Then XY is called a midsegment because it hits both sides at their midpoints. Okay, so if XY is the midsegment, then we know that XY is parallel to RS. And this is the fun part, XY is 1/2 of RS. Or you could say that 2 XYs give you 1 RS. So let's put that into practice, okay? It says find the value of x. So because we've got these congruent parts here, so C is a midpoint of there, B is the midpoint of that side. So we know that this purple line is the midsegment, And we know that these two lines are parallel. And we also know that if we have two x plus 19s, two of this guy, then we get the x plus 29 side. And then you can just solve for x. So distribute that 2 right on through to the parentheses and solve for x. Looks like we'll subtract x from both sides and subtract 38. And then we get x equals negative 9. Okay, try this one on your own. Pause the video, see how you do. Right, so we have QR is the midsegment. It's parallel to the yellow part, YW. And because QR is the midsegment, we know that 2 x plus 3s, 2 of the QRs, equal 1 of the x plus 9s, or the YWs. And then we can solve. 4x minus 6 equals x plus 9. 3x equals 15. And x equals 5. So similar to that, we've got parallel lines and proportional parts. So when 3 or more parallel lines cut 2 transversals, okay, let's stop there for a second. So we've got 3 or more parallel lines. We've got line 1, line 2, and line 3, okay, and they're cut by T and S. Those are the transversals. Then they separate the transversals into proportional parts, meaning that A over B equals C over D. Those are proportional parts. Similar, very similar to that, is this. If the ratio of the parts is 1, then the parallel lines separate the transversals into congruent parts. Okay, what? Okay, that's a little bit confusing. So we've got our parallel lines, right? Line 4, line 5, and line 6. And what this is saying is that if UV equals 1, U over V equals 1, meaning that U and V are congruent, then we know that W and X are also congruent. So here's what this looks like. We have our parallel lines, yeah? Okay, now we've got our proportional parts. And let's see, we've got 4. We've got 4 here, but we need to know what this is, so we have all of our proportional parts. So 10 minus 4, that's 6. Now we can set up our proportion, right? So 2x minus 10 over 9 equals 4 over 6. Cross multiply. So we're going to distribute that 6 through the parentheses. Again, pause the video if you need to get caught up writing. 12x minus 60 equals 36. We'll add 60 to both sides. 12x equals 96. Divide both sides by 12, and x equals 8. Okay, now you try this one. Pause the video for a second and see how you do. All right, so check your work with what I've done here. We've got our parallel lines, and that shows us proportional parts. So I set up 6 over 5 equals 12 over x minus 1. Cross multiply. Put that 6 through the parentheses. We get 6x minus 6 equals 60. Add 6 to both sides. 6x equals 66. And divide by 6 to get x equals 11. Okay, here we go. Last one. I think this is the last one. Find the value of x. Now, this is cool because we have our parallel lines, right? And what we're noticing is, look on the left here. Look on the left. What do you see? We've got those congruent markings. So if those two proportional parts are congruent, then we know these guys are also congruent. So we know that 5x minus 7 equals 2x plus 2. And now we can solve for x. So 3x equals 9, and x equals 3. And there we go. So have fun with your homework, and I'll see you next time. Thanks for being here.